Hello, everyone. My name is Samia Ashref. I am a Google developer expert in Flutter and Dart, a Women Techniquers ambassador, and also a Flutter developer. And in today's session, I will be talking about architecting your Flutter app using block state management. This will be a second part to the series. So there was previously there is a first part where I talked about what is block and what are the basic block widgets and how we can architect our app using the block architecture. And in this series, I will be talking about in this session I will be talking about block, but with code and seeing how we can write the block code. So this will be our agenda for today. We will have a quick recap of the block widgets because it is required to understand this session. We need to brush up through those block widgets and also a block with counter example where we will write some events and see how the states are emitted and how the UI responds to the events and triggers. So, with that, um, let's do a quick recap of the previous session. In the previous session, we talked about view block models repository. So, basically, how you can form an app architecture. And the reason why I have separated view logic and data provider here is because your app should never have logic mixed with UI, which means the UI should be only having widgets that is going to draw the UI components, and logic is an entirely separate module which is going to take care of the logic of the application, and it should never mix with the UI. And data provider is where the APIs will be uh, where the APIs are stored. So our uh, interest here is on view and logic. And if you see here, logic is having three components: block, models, and repository. So all of these are responsible for the logic of the application. That is the reason they have been clubbed into one layer. Now, the way data travels here is first through the UI, where there will be an event trigger. An event will be triggered in the UI, and that event will then be in the block event. It will call the particular block event, which will call a repository where, let's say, it's a login API. So in the UI, when the login button is clicked, it is going to trigger the login event. Now, from the block where we have the login event definition, it is going to call the login API in the repository, and this API is stored in the API service where the API will be called and there will be a certain response to this API, right? So let's say the login was successful. Now, from the API, the in the repository we will have the response, which is login was successful or not successful. Now, the response will be decoded and we will have a model. We will store the data in the form of a model so that it's easily accessible in the UI. And from repository back to the block. Now, login event will have particular states. So it can be an authenticated state or login failure state, or it can be any state. So basically, like if the login was successful, we will have a state. If the login was unsuccessful, we will have another state for that. So that is then going to be mapped and travel back to the UI. So this is how the data is going to flow in this manner. So you might be following a different app architecture, and that's completely fine as long as the logic and the view does not mix together. It's good to go. So this is what we discussed, and if you want to know in depth about these layers, then you can visit that session, and there we have talked more about it. So view only contains UI widgets. Block contains calls to the events, states, and even calls to repository. So that is the main logic of uh, the app is in Block, but Block is also dependent on repository and models. Models contain object definition that is used to store the data which will be returned from the API, and the repository contains the calls to the API. So this is a simple app architecture that I have, and today we will be exploring them with an example. So next is where we will do a quick brush up of the block widgets. In the previous session, we discussed about block provider, where block provider is like a layer which surrounds the widgets. Now, if we want a particular widget to be able to access block events and block states, then we need to wrap that entire widget with the block provider. Otherwise, we cannot access the events and the states of that block. So that's the reason block provider is an important widget, without which we cannot carry out any block functionality. So next is the block builder. Block builder is used to build the UI as per the block state. So every time the state of the uh, block changes, then a rebuild from the block builder will be triggered. So this will ensure that whichever state has to be in the UI, it will be built by the block builder. It takes care of building the UI. Block consumer invokes a functionality in response to a state change. So uh, they are optional. We don't necessarily or mandatory need to use this. But if you have any functionality that requires block consumer, then we can use block consumer, which invokes a functionality in response to a state change. And also block selector, which filters the updates by selecting a new value, and which also is based on the current block state, which again, it is not mandatory. The only mandatory here would be block provider and block builder, because we want to build and rebuild the widgets as per the block state. In the last session, we did not cover what was block listener. So here is a little definition about block listener. It is a type of block widget which listens to state changes from a block. Now, an example of this would be, let's say, login. Now, once we have entered our email and our password, and we are going to first check if it matches the email format. And once we call the API, the login API, so we will get a response. Let's say the API, the login was successful. The user exists. The user has entered the correct password and email and password. And once we call the API, the user was successfully registered, successfully authenticated. So once that happens, we want to redirect the user to some other page. So we can do this using the block listener widget. And the way we can do it is we are going to listen to the state of this block, login block. And once we know that the authenticated state is emitted, authenticated state is only emitted once the user is successfully authenticated. So once the authenticated state is emitted, we now know that we want to redirect the user to the login page. This is where we can use the block listener. It listens to the state changes from a block. Now, when the from the login initial state, it is going to go to login loading state, and then if the user is registered authenticated, authenticated state, this is where we will redirect the user. And if the user was not authenticated, if there was some um, if the user entered a wrong email and or a wrong password, then obviously we are not going to authenticate them, and even the API is going to return it's not going to authenticate the user. So in that case, it will be unauthenticated state because the user entered wrong credentials. So when unauthenticated state is emitted, we can then show a snack bar saying user credentials are wrong, so it or invalid credentials. So this is how we can use block listener in our app, and not just for navigating, you can use it for anything. It executes a callback in response to the block state changes. So we can use it for navigation to show when it's an authenticated user, navigate them to homepage, or showing a snack bar when it's an when the user is not authenticated. We can show a snack bar saying invalid credentials, or any other scenario. We can use the block listener, and it's a very useful widget because it does so many things. It helps us to navigate the user to homepage. It even helps us to show a snack bar, a dialogue. It's a very versatile widget, and we can use it in so many different ways. So that was about block listener. Again, it's not a mandatory widget. We can still use the block functionality without block listener. Only mandatory widgets would be block provider and block builder. So that was about block listener. Now let us explore an example. Now, this is a counter example. This is not the default app that we have when we create a Flutter project. So it's a little different because here we'll be having two buttons instead of just the increment button. We'll be having a decrement button and an increment button. So it's somewhat similar but not same. So this is my counter event now. Uh, so I will be having counter block, counter event, and counter state. So this is my block classes, and this is the counter event class where I'm going to write all of the events of this app, all of the events that I want the block to handle. Now, counter block will have these counter events: number increase event and number decrease event. As the name suggests, number increase event is going to increment the number or increment the counter value by 1, and number decrease event is going to decrement the counter value by 1. So we are simply going to register them in our counter events class, and it is going to extend the number increase event is going to extend our counter events class, and similarly number decrease event is going to extend counter events class. So these are the two events that I have so far. Next we have our counter states. Now we're done with the counter event. So for every event there will be a particular state, one or more states, right? So these are our states. We will only have two states because obviously when the app is open, the counter value will be 0. That's the initial counter value. And once we perform an operation on the counter value, let's say if it's a decrease event, number decrease event, it is going to decrement the counter value. So our counter value is updated. So two states, initial state and update state. Update state is where the value of the counter or the counter value is updated. It can be an incremented update or decremented update. And yeah, this is these are the two states for our counter block. So we have two events and two states. Initial state is when the counter value is 0, and update state is when the state is updated and the counter value has changed, either incremented or decremented. Before discussing counter block, we need to understand what the counter block actually does. It handles the logic of the application, which means it handles the decrementing and incrementing of the counter value. Because right now, those are the logic of our application: two operations, to decrement and to increment the counter value, and it handles the events that are triggered by the user. So we have two events, and every time the user triggers an event, the definition of that would be in block, and also it updates the states accordingly. So every time the user triggers an event, certain operations will be performed, certain code will be run, and after that, we will be emitting the states. So, this is what our counter block does. It handles the logic of the application, handles events that will be triggered by user, and accordingly, it updates the states as per those events. Now, here, because we have two events, so our counter will be listening to two events: number increase event and number decrease event, as we discussed in the counter events class. Now, when a number increase event is triggered, increment num function will be called, and when number decrease event is called, a decrement num function will be called. So we will be looking them. We will also switch to the code and see how it all works. But I just want to give you a glimpse of what is happening in the code. Now, increment num and decrement num are functions which we will be defining them in the counter block class. And yeah, so if you want to add any other function, like if you want to decrement or increment the counter value by 2, then we can add a number increase by 2 event and have a separate function for it, because obviously it will do some other thing. So we have two functions, increment num and decrement num. So increment num, what it does is it takes the event that the block was listening to, or it takes the event which is associated with that function, and it also is going to emit the state. So when increment num function is called, it is going to increment the counter by 1, and it's going to emit a state. Now, out of all the counter states that we have here, it's going to emit update state. Now, what if you remember the update state? What it does is uh, it has a constructor where it takes in the value and returns that value. So here it does the same. We are going to call the update state class and pass the current counter value. So when the state is updated, it returns the most recent value. So that is what our increment function does. It simply increments the counter value by 1, and then update state is passed to update the current state of the app. So let me quickly switch to VS Code, where we are going to see how it all works. So I hope you all can see my VS Code along with the emulator. So a quick restart. So start of the application, I have the counter value to 0, and this is what I said. when the counter is initialized, or this is the initial counter value, which is 0. Uh, so, yeah, I have a very simple app here which calls the material app calls counter with block. And I have here with me two widgets, a build widget and a counter widget. Now, all the widgets that you see here, the text widgets and the button widget, they're all in counter. I have clubbed them into one widget. And here I have a very simple block provider widget. And what I do here is the entire counter widget, it will be only called when the state is initial state or the update state. And the reason is because when the state is initial state, the counter will have a 0 value. So that's the reason I'm going to say counter and initial the counter value to be 0. And when it is an updated state, when the value of the counter is updated, we are going to rebuild the widget and pass uh, the counter value as per the block state. So this is how I have structured my home view. Now let us look at what the counter widget does. So a text widget. So understand what are these text widgets. And in a row, I have two buttons, elevated buttons with the minus and a plus sign, which simply decrements and increments the value. Uh, and when you press them, an event is going to be called. Now, what is that event? It is the block event. The counter block number decrease event when the minus button is pressed, number increase event when the plus button is pressed. So this is how the widgets are laid out. Two widgets in a row, two text widgets, and here you can say this is where a little block logic happens here. Block provider, like I said, it's a mandatory widget if you want to access the block functionalities. Now, this will ensure, because I have wrapped the entire thing with block provider, it will ensure that I can make use of the block functionalities. And block builder is going to rebuild the widget whenever the state of the block changes. Now, state, initial state, context comma 0, where we will be having which is the initial state of the application. And every time a plus or a minus button is pressed, then we have an event triggered. Now let us go to the event and see what is happening there. So two events, number increase event and number decrease event, both of which extend the counter events. Counter state, which counter states, where I have two states, initial state and update state, again, both of which extend counter states. Initial state does not do anything because we just want the counter value to be 0, and we are anyways doing it in the view here where I'm passing the value to be 0. So we don't need to do anything here. Whereas the update state, we are going to store the counter value and then access that in the view. And counter block is where the entire block logic is present. Every time I call the minus button, what happens is this block is going to listen to these two events. And whenever the minus button is called, it is going to be a number decrease event. So this block is listening to these two events, and when number decrease event is triggered, it's going to call the decrement num function. And our decrement num function, what it does is First, it ensures that if only if the counter value is greater than 0, then decrement the counter value by 1. Otherwise, let it be 0. So this is to ensure that we don't end up with minus values. If you want minus values in your application, you don't need to use this if function. And once we have our counter value updated, we are going to emit the update state with our new counter value. Also, if the number is 0, then the counter value will not be updated, but the update state is still going to be triggered because it is not a part of our if function. Even if we don't uh, comply with this if function condition, the emit update state is still going to be triggered. Update state is still going to be called. So similar thing is for increment num, where every time I press the plus button, number increase event will be triggered and increment num function will be called, where counter value changes by 1 and update state returns the most recent counter value, which is um, previous counter value plus 1. So it increments the num by 1. So this is how we can trigger um, events and emit respected states. Let us try an example here. Let's try adding another functionality where we will be incrementing the current counter value by 2. So just to give you an idea of how it all works. So let me add another button. I'll just simply copy the code and make the changes. So here we are going to increment by 2. The current plus button increments by 1. I, however, want to increment by 2. So I have a plus 2 button. And right now it calls number increase event, which increments by 2. So let me remove that. And now it doesn't do anything. This button does not do anything. So let us register an event, and I can call this as number increase by 2 event. We can call our event with any name, but we need to ensure that it always extends the same counter events class. This class name can be, however, anything. So now we have our number increase by 2 event. If you notice, we don't need a new state because update state is anyways going to return the updated value, counter value. Now, if my counter value changes by 1 or if it changes by 2, it still does not need a new state because same update state can be used to return the value. But here we need to add another event on number increase by 2 event, which is the one that we just created. We will add a new function. So here we have a function that increments by 1. We can simply add a new function, increment num by 2, where the event that it takes is not number increase by event. We need to change this because it is corresponding to the events that we have here. We just created number increase by 2 event, and we are just going to add the same thing here. Every time number increase by 2 event is triggered, then we are going to call increment num by 2 function. And here what we are going to do is the current counter value, instead of incrementing it by 1, we are going to increment the counter value by 2 and emit update state. If you notice, we are not going to change any code on the state on the emit here, because we are going to use the same update state to emit the updated counter value. So now that we have registered the event and added the functionality or the logic to that particular event, let us go to home, and here we need to add that or call that block event. So we're going to say, so we have our event here. So we're simply going to say context.read counter block add number increase by 2 event. So here what happens is, let me quickly do a restart and then we can make use of that block event. Okay, so now that we have our app restarted, if I click on +2 button, now it increments the counter value by 2. And if I just click the plus button, it increments by 1. So this is how we can add the block logic. You can try and add another button here which will decrement the current counter value by 2 instead of the 1 by 1. So this is how you can also make use of the block functionality to add any kind of block logic to the application. And let me quickly go back to the slideshow. So yeah, that is how we can add events and states and write the logic for any kind of block that we want, like a login block and authentication block. So that was a simple example with the counter block where I had two buttons, minus and plus, which triggers number increase event, number decrease event. And we also saw how we can add a new button, write the respective event class and the block functionality or the block logic, and call them in the view. And we also saw how we did not add any logic to the view. Any logic should only be written in the block class and not in the UI class. In that way, we can reduce the load on the application. And also because block builder triggers the rebuilding of the UI, we need to ensure that the UI does minimal things and only building the widgets and not the logic, because then we are going to heavily make it more populated with lot of logic, which is not a good thing. And always keep the logic separate from the UI. So that's all for today. I hope that example was helpful and you gained some knowledge from that. And if you have any doubts regarding block or how to write block for a particular functionality, you can always reach out to me. Here are my socials, and my links will also be shared. Um, so, yeah, reach out to me if there is anything that you want to know from me or anything. Also, you can post your questions. If you have any questions, you can drop them in the chat box and I will answer them.